let's look at what are the limitations of traditional systems or existing solutions. Why do we actually need some new frameworks like Hadoop or Spark that have come up today to solve big data problems? So typically what happens is, this is a diagram which shows you what typically happens. So typically instrumentation is basically the sources of data, the place from which data gets generated. So you can think of it as any source, like some sensor who is generating data, or some mobile phones are generating data. So it could be any source, right? So typically we first collect the data in a storage only grid, right? So there are network area storage or storage area networks, right? These technologies are there where you actually first collect the data. You collect the data, you store the data into huge array of disks, and that data stays there for some time, right? And then what happens is, you move some of the data from this storage only grid to a compute grid. So the compute grid is a separate grid which has computing power. So the storage only grid has some computing power, but you cannot compute or process the complete data here. You move this data, right, to a computing grid where you have a lot of machines that can process this data. You process this data, and then you come up with some information out of this data, which is then put into RDBMS, right, relational database management systems. And then on top of that, you can run your business reports, right? So for example, the use case that we just talked about, right, your CDRs could be going into storage only grid, right? And then along with a lot of, let's say, browsing data, a lot of other data sources could be generating data, and every data source, data from every data source is being collected on in storage only grid. And when you have a use case, according to the use case, you'll move some of the data here, you'll process that data, and then you'll come up with the results. You'll put those results into RDBMS, and then your business reports can pull that data from RDBMS, right? So typically what happens is, 90% of your data doesn't even go to the compute grid, because it is very expensive operation. To move data from storage only grid to compute grid, it is very expensive. And then processing that data, basically you need a lot of hardware capacity, which is generally not available in case of traditional systems. So in traditional systems, basically what happens is, you generally have big servers, right? But it's not easily possible to scale it up, right? So which means you cannot simply scale beyond a given limit, right? Because you can put, let's say, 100 gigs of RAM, you can put 24 core processor in your machine, but that's about it, right? There is ultimately a limit on beyond which it's difficult to scale a server, right? So that limit is basically a killer in case of existing solutions. So what happens in case of Hadoop based solutions is, your storage and compute grid, they are combined. So basically this is the unique selling point of Hadoop, where you store your data on some of the machines in distributed fashion, and then you can process your data then and there only, right, on those machines itself. So which means you don't have to move your data from any storage only grid to a compute grid. You can process all of your data in the same cluster itself, right? And on top of that, more important thing is, Hadoop is a scale out architecture rather than scale up architecture. So the difference between scale up and scale out is, like in case of scale up, you have a machine to which you keep adding more resources. So for example, if your machine was, let's say, 50 gig RAM, and let's say 10 terabyte of hard disk, you can simply add more RAM to this machine, more disk to this machine, but ultimately there is a limit which you hit very soon, right? But in case of Hadoop, you can have very slow end machines, right? But you can keep adding more machines to your cluster, and your cluster just keeps growing up. You don't need to actually change any of your software implementation. If you just add a few more machines to your cluster, Hadoop can just take these more machines and use them for processing your data, right? Which is the unique selling point of Hadoop.